So this is the first activity. Consider a steam power plant operating on a simple ideal Rankine cycle. So steam enters the turbine at 3 megapascal, 350 degrees Celsius, and is condensed in the condenser at a pressure of 75 kilopascal. So determine the thermal efficiency of this cycle. So first, draw the diagram. Draw the diagram to make it easier to understand. Okay, so steam enters the turbine. Enters, it means steam enters the turbine, so it means it must be 3, right? Okay, so the temperature of 3, T3 equals to, this is enter turbine at 3 megapascal, P3, pressure 3 equals to 3 megapascal, temperature 3 equals to 350 degrees Celsius, and is condensed in the condenser at a pressure of 75 kilopascal. Okay, in a condenser, so it can be pressure 4. It doesn't matter because the pressure 4 and pressure 1 is actually equals. Therefore, it can be pressure 4 or pressure 1. So pressure 4 equals to 75 kilopascal. So determine the thermal efficiency of this cycle. Thermal efficiency equals to Q in minus Q out over Q out. But how to get that? Okay, so how to get Q in minus Q out? You need to find the Q in first. Okay, so in order to find the Q in, you need to find the H3. So how to get the H3? Using properties table. Okay, properties table at pressure of 3 megapascal and temperature of 350 degrees Celsius. Okay, so when you have find the properties table, find the value of H3 at this state. Okay, at this state. Okay, so you can be able to find H3. So how about H2? So H2, you need help. You need to solve this one, H2. Where can you get the H2? You need this one, H2. Okay, H2, you can solve it by using this equation, or you can solve it using this one. Okay, so work pump in equals to H2 minus H1. But do you have H1? Okay, so you have two unknowns here. So if it's two, you have another options. You can solve this first. Do you have V? Do you have P2? Do you have P1? Do you have P1 and P2? Do you have P2? Okay. Let's try any equations that is possible to be used. Okay. What do you have? It's condenser. Okay, you have P1. Yes, you have P1, and P1 equals to P4 equals to 75. So you have P1. So if you have P1, do you have P2? P2 equals to P3. So if you have P3, it means you have P2. Okay, so this can be solved. Do you have V, specific volume? Okay. Do you have specific volume? Specific volume is actually V at specific volume of saturated liquid. Okay, so if you have pressure, okay, if you have this pressure, I think you can get the saturated liquid specific volume at this pressure, right? So if you have that, you can solve this. Work pump in equals to this value, and the value of work pump in equals to this. So you have the value of work pump in, you have the value of what is it? Do you have the value of H1? Yes, H1 is also H1 equals to HF at pressure 1. Okay, because this is a saturated liquid. Okay, so you have value of H1, you have the value of V1. You can solve this. You can get the work pump in. You can get H1. Therefore, you can get H2. Okay, do you understand? Okay, so when you get the H2, insert the value of H2 in here. Okay, you have the H3 just now. Therefore, you can get the Q in. Okay, so for the Q in, you have the value of Q in. Do you have workout? Okay, do you have workout? No, you don't have the workout. So you need to find the you need to find the Q out at here as well. So can you get the Q out? The same process. So can you get H1? Yes, you already have the H1. Can you get H4? So H4 is actually at here. Okay. What is the properties? Can you get the H4? H4. So work pump in H4. Okay, H4 you have pressure, right? You have the pressure. Can you find H4? Okay, from that situation. Oh yeah, if you have T3, if you have T3, it is the S3. Yeah, another one you can use is the 3 and number 4 is isentropy, right? So if you can find at state number 3, if you can find S3, right? Actually, you also can get S4. S4 is equal to S3, okay, entropy. So if S4 equals to S3, so you have two things already. You have pressure and you have entropy at state number 4. So you need to go to that table and you need to match find the value of entropy, that value that you gain from T3 just now, and match with the pressure of 75 kilopascal, and you might need to use some interpolation to get the H4. Okay, so when you get the value of H4, you will get the Q out. When you get the Q out, so you can solve the thermal efficiency at here, right? Okay, so it's a quite a long process, but if you really understand this, you can work this out. You need to understand this. Okay, so try to do the activity.